Hi there, welcome to another video in Geometry with Mr. Yang. This is part B of 1.4 video. 1.4 we learn a lot of different properties to help us with proofs. We're going to learn more rules, but these are postulates. These postulates will be very important ingredients in order for us to truly become successful in the round of proofs. So first, I don't know if I already went over linear pair. Linear pair are any two adjacent angles where two non-common sides are opposite rays. So bottom line is the picture of two linear pair angles will look like this. So linear pair refers to two angles. So like angle. They're adjacent. Adjacent means next to or touching. Adjacent often share a common side. So two adjacent angles will be like angle ABC and angle DBC. These two adjacent angles also happens to be linear pair because they share the same opposite rays. Bottom line is they are called linear pair because they do form a straight line. Now these two, when glued together, makes a straight line. All right, there's a theorem that talks about linear pair. Linear pair theorem says if two angles forms a linear pair, so they form a picture like that, then they are supplementary. By the word supplementary, it means they are going to total 180 degrees. And this is going to be true all the time, regardless of the size of angle 3 or angle 4. May I also remind you that for these next 5 postulates, you have to draw pictures. Without drawing the pictures, it will not make much sense to them. So draw the pictures along with the definitions and understanding geometry. Postulate 3 says, through any 2 points, you can have exactly one line. What that means is, any 2 points you graph, say on a piece of paper, wouldn't you agree that you may only use the ruler and draw one straight line passing through the same point? If you disagree, I mean, you could try another line. But it doesn't matter if you draw another line or not. If you draw another line that's going to point in a different direction, that would not be one line. This will be a different line than the one that was true. So then it violates the rule of exactly. Exactly means also only. If you were to place another line that overlaps on top of the existing line, then that is not a unique line anymore. You're using the same line that was drawn previously. So that's not a different line, a new line anymore. Okay, postulate 4. Postulate 4 says, through any 3 non-collinear points, there exists exactly one plane. Which non-collinear, non means not, collinear, co means same, linear means line. So 3 points that are not on the same line. So one of the points should be either higher or lower. So offset it. It's saying that in this situation, there is no way but to place one piece of paper to touch all 3 of these points. In other words, when you're provided any 3 points, you can only, that's what it means by the word exactly, you can only put one piece of paper to connect all 3 points, not a third one. Not a second one. Because if you try to force another piece of paper or another plane, say it's vertically, okay, that vertically one fit just right, could touch B and C, but there is just no other way to also touch point A. Alright, so almost like that. Postulate 5. If 2 points lie on a plane, then the line contained that also lie in the same plane. So line means touch. They are given 2 points. They are on top of the same plane. Okay. So what this is saying is, like in this image here, you will have no choice but to have a line. So any line that will connect between 2 points have to also live on the same plane as were the 2 other points. So the main concept is that the line that was connecting the 2 points, it couldn't live anywhere else. That line couldn't be, okay, that line is not on the paper completely. It's just on the paper somewhere. No, it has to live on that paper entirely. Okay. Next. Pasha 6 says the 2 lines intersect. Then they intersect in exactly 1 point, or only 1 point. That kind of makes sense. Okay, imagine you have 2 rulers. You make them meet. If they meet, where do they meet? Just that one place, right? They don't meet in 2 places, not 3 places, not 0 places, 1 place. So exactly, so only 1 place or 1 point. Postulate 7. This one says, if 2 points intersect one vertical, then they both intersect in exactly 1 line. So what that means is, so imagine you have a horizontal paper, a vertical paper, they will meet each other. If they do meet each other, the situation that will happen is they will overlap. And they don't just overlap at one spot. Each of these little dots are considered one spot where they do overlap. And if you were to collectively gather all these points where they meet each other, those overlap also known as intersections, will be a straight line. So the 2 paper will blend in the middle, like purple, like that. Exactly 1 line means you don't get their intersection being a bigger area or small area than 1 line. So exactly 1 line. Okay. Next, we can try some examples from the classwork and homework. This one asks you to find the value of y. So you will mostly just use the postulates you learned from section 1.1 and section 1.2 for these latter homework problems. Okay. Y is the midpoint of the segment XY. What you will have to do is, now if a picture is not provided, you will have to figure out a picture. But I'll provide a picture for you just to help you out here. Imagine like a point Y is in the midpoint, which means it's in the very dead center. They give you some values to help you out here. XZ is 8x minus 2, and YZ is 2x plus 1. So Y to Z, 2x plus 1. Since we already been told y is the middle point for this entire length, so if the second half is this value, wouldn't that make the first half also the same value? Okay. Now these are actual numerical values, but we just have the x in the way. So the only way to get everything demystified, what you have to do is probably figure out this mystery variable x. And there's no way to figure out variable x except through the help of an equation. So here's what you have to do. You have to figure out how to make all 3 of these expressions to make an equation. What you normally need to do is you need to add things together. Would you agree? So according to segment addition postulate, the sum of the pieces equal to total pieces. So that you kind of have to remember. That concept will be applied in many, many different situations. The sum of the pieces should total to the entire piece. Agree? Doesn't the first half, second half total equal to the entire length, which is ax minus 2? So if you know that far, we know the sum or the total is this. Then you have to combine the first 2 pieces together. 2x plus 1 first piece plus second piece, 2x plus 1 second piece equals to the total value, the total length value, ax minus 2. Then you just have to solve for x here. For x plus 2, all right, ax minus 2, you could go ahead and take away the 4x. That will be 2 by itself equals to 4x minus 2 plus 2 on both sides. 4x equal to 4. Divide 4 on both sides. So if you divide 4 on both sides, you get x is equal to 1. So that's the final answer. Similar idea here. SV is an angle bisector of RST. Okay, so basically what you should do is every time they give you some values, right away start inserting those information in the diagram. Thankfully, I provide diagram here. If I don't provide diagram, just remember you need to draw an angle. Bisector means it's something that's going to cut the angle into two equal pieces, two equal piece angles, so two small angles. RSV is the first half. RSV, so 3x plus 8. That value represents this tiny corner here. RST represents, okay, RST, angle ST represents the entire angle. So 8x minus 14 degrees. All right, if this is an angle bisector, it means it breaks the first half and the second half in two. The first half is already known as 3x plus 5. The second half is also 3x plus 5. All right, how do you think we should do this? Of course, our goal is to demystify the actual value of each of the angles by getting rid of x. But x is not easy to figure out. The only way you can solve for x is with an equation. So using the angle addition postulate, just like segment addition postulate, the sum of the two pieces must equal to the total piece. Agree? So what are you summing? You're summing the first piece and the second piece equal to the whole piece. The whole piece is the entire angle 8x minus 14. The first piece, 3x plus 5. The second piece, combine that with second piece, should total to the entire big angle. So what is 8x minus 14 is the size of this big angle here. All right. So then from here on, you can go ahead and just combine like terms. 6x plus 10 equals to 8x minus 14 minus 6x on both sides. You get 10x equals to 2x minus 14. So what you might want to do is you might want to move the 14 by adding 14 on both sides. That will give you 24 equals to 2x divided by 2 on both sides. X is, so final answer x is 12. They're only asking for x. 12 is the answer.